So now let us discuss how we can generalize the binary search to multi-way search. Okay. So we still have our search function to write. We take input as value v to be searched, and we know the left index and the right index within which we have to search. Okay. Till now we have seen that if the values are sorted, we can do binary search. So we were taking the middle element and partitioning into left partition and right partition, and then depending on this comparison we were selecting one particular partition for search, and that's how our binary search proceeded further. But why limit ourselves to only two partitions? Okay. So what if I try to do a three-way search? So given this array, I would select now two elements and create three partitions of my array, and I will compare my search value v with this element as well as this element, and now there are three possibilities, or more than three. Okay. First possibility is that the value v is less than this particular value. Second is it is equal to this particular value. Third is it is between these two values. Then fourth is it is equal to this particular value, and then last possibility is greater than this value. So five possibilities we have, and what will happen is every time I will reduce the problem size by 1/3. So what will happen is I will still have my asymptotic time complexity as theta of log n, but it will be base 3. Okay. But now difference is that every time I have to do perhaps two comparisons in worst case. Previously only one comparison was enough. Okay. So let's try to write down the overall idea of this method. So first of all, I will check if my left is greater than right. Okay, that's the way we are checking if we are done with search. Okay, so if my left is greater than right, in that case I have to return -1. If that's not the case, then what should we do? Then I should compute the, let's call this as say pivot 1, p1. Then I have to compute p1 as equal to my left plus right minus left divided by 3. Okay. And then I'll compute my second pivot as left plus 2 multiplied by this same ratio. Okay. So right minus left divided by 3. Okay. So for example, the array that we had of 10 elements from 0 to 9, in case of three-way search, what will happen is our left is 0, right is 9, and our p1 will be 9 minus 0 is 9, 9 divided by 3 is 3. So I'll have pivot as 3, and 3 multiplied by 2 is 6. Second pivot will be 6. So one partition from 0 to 3, second partition from 3 to 6, and third partition from 6 to 9. And now I have to ask question. Okay. So first question I have to ask is, if the value that I am searching for is less than get element p1. If that's the case, what should I do? I should search in this particular partition. Okay, fine. So what will I do is I will return the result of searching the value v in left and p1 minus 1, because I have already compared with p1. Okay, so that's what will happen. Otherwise, what will I do? I will check if a value is equal to p1. In that case, I have to simply return P1, the index where I found it, if my value is such that V is greater than P1 and my V value is less than P2, not the index, it should be the get element at. So I'll denote it using this symbol. Okay, so this means that get element at particular position. So we'll say P2. Okay, if that's the case, then what should I do? In that case, I should return the result of searching value V in the range. Now P1 plus 1 and P2 minus 1. Fine. Otherwise, what should I do? I should check if my value is equal to element at P2. In that case, I know what to do. In that case, I have to simply return P2, and now the last remaining thing is that otherwise I have to search in the last section. So that will be my last line. Otherwise, return the result of searching in the last partition, which will be V P2 plus 1 up to right. Okay, and that's the end of my function. Okay, so that's my three-way search, and now you can generalize it to even k-way search. Okay, so again, try running this particular pseudocode on example input. Again, try different cases, test cases. Try test cases where value that you are searching for is actually present in the array. Try cases where value that you are searching for is absent in the array, and check if this works properly. If it doesn't work properly, let me know the problems and we'll discuss them in the interaction session.